All right, so good. So what I will start with today is to have this introduction to trainings. I will start with the basics and also show you the basic data groups or data formats that you basically need to start a project. And we will touch upon a little bit on the metadata and how that works. And I'm going to give it a project name. So I'm just going to call this training. And today's date is the 24th, I think, of April. And now I can set some key numbers. I can set the seabed level. So seabed level is where we will put a flat auto-generated seabed. If you don't have access to any bathymetry data, we will create one automatically, but it's completely flat. And this is where you put the depth. So 1200 is a default, but you can write whatever you want. If you write a positive number, it will still become a negative number. So now I will choose 500 meters. I can choose my unit system. And for this version, it's only for the annotation. We operate in meters on this version. The next version will also support field units, imperial units, when it comes to sizes and dimension. But this one doesn't. It's just for the values. And by values, I mean metadata and that kind of thing. So I will just leave it to metric. The coordinate reference system is where you can set your link to a GIS system. And every GIS system needs to know what kind of reference do you have in your project. If you want to use UTM mapping sources, the UTM map source just needs to know your reference system. Where are you in the world, basically? And if you click this, you will get a link of all the different EPSG, what they called, projection systems. And you need to know this number. This is something that not everybody goes around remembering. So it's wise to talk to the mapping department before setting this. And they will give you the correct reference system. It's just to make sure that the maps are projected correctly. So I've just put the start date and the end date in, and that's just to initialize the activity part of the software. This is also something you can change during the project if you want. And the last parts of this is basically predetermined or predefined data inputs. So if you want, you can have a list of customers that you can add on. The country just says, you know, do you want to tag into a specific country? It's more for logging purposes and cataloging purposes in the database. The Wms Configuration is a place where your mapping team can predefine different maps with the right CRS and the right data points. So that's also something that we will save for a more in-depth walkthrough. But it basically means that if you pre-populate maps, the users of Fieldap can then go in and say, I want a map of the Mexican Gulf, I want a map of Angola, I want the map of the North Sea, so on. And then you will get the right configuration because it's pre-made. The last part down here is where you can play around a little bit with numbers if you want to. If I click this connection settings, I will get a list of all the piping and umbilical and other kinds of connections that has been defined. And you can see that I'm not able to change anything. This is defined on an account level, and only the account administrator can do any editing or updating of this list. So here I'm just seeing this is what's been defined. This is what I have to work with. And if I identify that I need new ones, I need to talk to this account administrator and ask to get it added in. In the three last ones here, we have something to do with cost. And Fieldap comes with a very simple cost server attached, the one we call basic cost server. It's only able to add values based on either manual input or metadata values. So currency settings allows you to choose the currency rate and add different currencies if you want. And this is for the project only. So whatever you do here is only for this project, your project. It will never be visible to anyone else outside of this project. So it's a local setting. Asset cost settings. Here you can go in and play around with numbers. So if you have a single plet and you know by experience the value of the single plet or the cost, you can put that in if you want to, and then choose the currency. And whenever you drag a single plet out into the project, this cost will be automatically added to the cost in the project. This is also something you can go back and change during the project, and it will update. And the same goes for connections. So if you know the price per meter for your oil production pipeline, you can put that in as a price per meter, and it will then auto-calculate that price. And you can go back and change it. So this is just a way you can play around a little bit with numbers, and you won't affect anything in BP at all, just this project. So I'm just going to choose save and open my project, and I get into Fieldap. And this is how it looks like when you have a brand new project. It's an empty project, and you are situated in 0, 0 as a coordinate. And 0, 0 is, I don't think, anywhere actually in the world. So it's the totally wrong place to be. So the first thing you want to do is try and get to the point where you want to be. Even if you have bathymetry files, survey files, well files, or mapping data, you are able to do that by utilizing those data directly. If you don't have anything like this, you just need a coordinate. So if you're able to get that coordinate from a document saying, I know the position of the FPSO, or I know the position of one of the wells, something like this, you can use that to actually transport yourself to that location. So one way of doing that is to actually just drag yourself to that place. It will take forever. So the other way is to just go into the asset library, which we have here in the tree view on the left side. We have an asset library, and here you can explode these folders and take a look what's inside. So here I have a Christmas tree, for instance. If I drag it out and I let go, I put it into my project. And this Christmas tree, if I zoom in using my mouse scroll wheel, I can say this is the coordinate. It's the XY coordinate, easting and northing. So if I know where this Christmas tree is supposed to be because I have the coordinates, you can just mark this entire square and just type in the coordinate, and the Christmas tree will then automatically go to that place. And now you can't find it anymore because it disappeared. So the way to find it is in the project view, you will find that this tree is growing based on the objects you put into the project. So underneath the folder assets, we have the Christmas tree that we just put in. I select it and I click the locate button. And then boom, I am at that specific coordinate. So now you have transported yourself to that point. So that's a way to get to a certain place in Fieldap. I'm going to delete that Christmas tree, and I'm going to start by uploading some data into my project. So I sent you in the email this morning, I sent some files. It was a link to a zip file containing some data. The good thing about that data is it's from Equinor. It's the Volva field, and Equinor released this data. I'm not sure if you're aware of it. It's a huge data dump done by Equinor. So they released all the data from the Volva field to be used by anyone who wants. And it contains terabytes of data. It's 40,000 files. So what we did, we downloaded a lot of the geometric data, and that's the data I sent to you. And this is data that we can freely use in training. So this is not sensitive data. So I'm gonna try and import a bathymetry file into my project. And to do that, I need to go to the Create button. Create allows you to create something from files or from servers. So this is where you create a 3D surface, a picture, a mapping service, a metrology service. I can create ports, a text, or wells. I can create a viewpoint, which is a saved view. If you zoom into some area of your field and you want to save that area as, for instance, drill center east or something like this, because it's easier then to navigate to that point, you can do that, as many as you want. And you can also create connections from files or a WFS server. Connections is what we call pipelines, umbilicals, mooring lines, everything that connects something to something else. And if you have a brownfield, you can import those data. If you have shape files or XY files of pipelines, you can load those files in by going to connection from file. If you have a ArcGIS system with actual engineering pipelines in it, you can also load the content from there directly. And I will show you that at the end of this session, how that works. So right now, I'm going to load in a 3D surface, which is my bathymetry file. So I'm just going to click there. And then I get this window asking me, what quality do I want? Do I always want to negate the C value? And usually you want to do this. Sometimes you have bathymetry that is actually also above 0 level, usually along the coast. Then you need to set this to no. If you want to load topography data, which we have done for some project in the Middle East, they want to have land-based drilling sites. You also need to set this to no. But if you know that your bathymetry is below the water, just put it as yes, because some of these geophysical specialist software, they tend to put the C value in positive numbers because they don't, it's not the depth, it's the height of the seabed. So that's why we put that in there. I can choose if this is a bathymetry file or not. This is important because 3D surface can also be other types of files. It could be a reservoir horizon. It could be a hydrocarbon map. It could be, you know, there's many different 3D surfaces. So this one I need to specify it is a bathymetry because I want my subsea equipment to actually sit on this file. So that's why we need to do this. And you can also choose to limit the import to your current view box. That means that I will only get bathymetry for this square that I'm looking for here now. But I don't want to do that. And then I'm choosing my file. So I'm going to go into this zip file that you got from me this morning, files for training. And there's one called volvabathymetry.txt. On my Mac, I can't click this because it's a text file. So I just need to say all files. Not sure how this works in Windows, but maybe you need to do the same. So the file contains two folders, one called reservoir, which has 3 different reservoir horizons, Hugin top and Hugin base, and one called BCU. So that's 3 different horizons that the reservoir engineer has extracted. And then we also have some wells. And the format of these wells I will show you as well before we import them. But right now I'm just interested in this. If you rename this file to .xyz, it will automatically appear. I haven't touched the files from Equinor, so they save them as text files, and we don't accept text files directly, but we We do, but we don't look for them. So just rename them XYZ and you will find them. So I'm just going to open this one, press create, and now I'm uploading my bathymetry file into the BP cloud instance. So this is the sensitive data. This is the whole bathymetry files. This could be huge. It could be the biggest one that I have been witness to was 120 gigabytes. And that took about 3 days to get through. So now it's uploaded, and if I click here, you can see the status on the file. It's there. Now it's inside my project. It goes pretty fast. Again, the project view will show you all the objects that you create or drag or upload into your project will list here automatically, project view. So you just expand layers, then you see 3D surfaces, and here you see my file. So I'm locating this, and this, so this is the bathymetry, the whole field. I click wherever I want with my left mouse button and drag. I can also zoom in and out. This is why it's nice to have a mouse while doing this. It's pretty white. It's a white square. And the reason why it's so shining white is that the sun is probably right above it. And in the project view underneath settings, you have world settings, which allows you to the whole North Sea of Norway is pretty flat in this area, but if you had some contours on your bathymetry, you can actually make them look better or enhance them by doing some modification of the light angle. So that's why this function is here. So this is the bathymetry file. If you notice up here in my right corner here, you have the X, Y, and Z of the mouse pointer. So the minute I go inside the bathymetry, you can see the C value picks up. So now you can see the depth. It's very shallow water here in this area of the North Sea. It's about 100 meters. So going outside of the bathymetry, it's 103.36. And the reason for that is that we put an infinite big bathymetry file on the lowest point of the imported one. So this one has the deepest end of this one is 103.36, and that's where we put our bathymetry underneath. And I can show you that by going into 3D, which you do up here in the top menu. You can switch between 2D and 3D. Clicking 3D will take me into the 3D layer. And now I can rotate my camera to take a more 3D look. And if I turn on this one, or turn off actually, I get my infinite seabed. So this is the seabed I'm talking about. That is 103.36, and it goes, indefinite. If you don't want this, because if you have this visible, you will not be able to see underneath this seabed. You have to turn it off by clicking this button called reservoir. It removes the visibility of this indefinite bathymetry, so it allows you to see what's underneath. So we had some questions around this. People who don't see their well data, that is because they have that enabled and you can't get underneath. It's like a big plate. So while I'm in 3D mode, and this is something that requires a little bit of practice to drive around here, the right mouse button controls the rotation of the scene. By holding the right mouse button down, I'm able to rotate my camera up and down. If I use my left mouse button, I'm clicking a point and I'm dragging that point towards me or from me. It's like if you put your hand on a big plate of wood and you just drag it, it's the same effect. And if I use my scroll wheel again, I'm zooming in and out on the mouse pointer where my mouse is. So the scroll wheel is something you're going to use a lot. So while I'm in 3D, I'm going to load some more data. And the first thing I'm going to load is the reservoir. And I have a reservoir horizon. So I'm just going to create again 3D surface because it is a 3D surface. I'm not going to choose bathymetry on this one because it's not. And I'm going to find these reservoir files that is in your zip file. Again, I need to just go all files on my Mac to get them visible. And I'm going to choose all 3 of them, but I'm going to take one at a time. So I'm starting with the Hugin top. The same procedure, press create, it will upload the file. And then you can actually see here in the tree view the status of the conversion from the cloud. So we have our own engine that will take this file and convert it into a visible 3D object. So now it's converting and it's uploading back the file, and it will automatically show up. So this is the reservoir, you can see it there. So this reservoir is here underneath. You can see it's minus 3,000 meters on my mouse pointer. So now I have, only by importing 2 files, a bathymetry and a reservoir depiction. So now let's try with wells. Same operation. I'm going to create and then well from file because I have the files. And then I need to find my wells, which are underneath the wells for import folder. And I'm going to choose all of them. So here you can take a multiple selection. And the minute I press open, I will get a window saying describe the well input format. The reason why we do this is because there's so many different ways of storing the well data. The columns of data varies a lot. And we have also discovered that some drilling engineers, they want to put the easting and the northing coordinate first. And some well engineers want to put it last. So it's not a standard. So to be able to do this, we kind of adopted the Excel way. So if you are familiar with loading column data or a huge amount of data into Excel, you're able to delimit the data into columns by identifying what is what. So this well is in a format that I will show you here. I have it there actually. This is the format of the wells. Again, this is the data from Equinor. So you might have a different format. But typically you have the measured depth. You have the incline, the azimuth, and you have the true vertical depth. That's always there. And then you have the X offset, Y offset, and UTM, easting and northing. So what we are interested in is just the easting and northing and the depth. That's the one we need, those 3. We don't care about inclination, azimuth, or measured depth. So I want to have the true vertical depth and the UTM E and the UTM north. So what I see here is that the true vertical depth is number 4, and this is number 7 and 8. First line is, let's see here. There, 41. That's where the first data appears. So I need to set the first line. And the northing was number 7. And the easting is number 6. And the depth was number 3 because it has 0. And then I can say use this for all the selected files. Confirm. So now I get some messages saying that the file contains the word feet. And this is just a warning that we have because there's so many, we will support feet in the next version, but there's so many people trying to load the wrong data. And this version only allows for meters. But the word feet is in there, so it just shows this message. So I'm just gonna press OK. Again, I haven't washed these files from Equinor, so. Man. You can see the wells appears actually. I don't know if you see them, but there they are. So it was a little bit of a button pressing operation there, but if you watch the files, it doesn't happen. And if I zoom in here now, you will see that I have the well data going from the seabed down into the reservoir. And if I zoom further in, you can actually see the curvature. So that's why we only want the X, Y, and Z, because we don't want to know the incline. We don't need to know the incline. We're just plotting the trajectory. There is a way to generate wells in Fieldap as well, and I can show you that in the last part of the session. Together with the Oleasoft integration, you are actually able to generate a well using incline and azimuth and putting the targets. It needs 3 targets, and it will actually create the well using an algorithm. But right now we just wanted to load the data. So these wells are pretty thin. If you want, you can make them bigger so they're more visible. And to do that, you just go into your project view again. And right now you will see that we have wells as a folder. And underneath wells, you have all the wells that we actually imported in. You can see they have a well and a well bore. So you can have multiple well bores connected to one well. Sometimes we have wells that have 4 or 5, even more well bores, but only one well head. So this is a way we can use that structure to define wells with multiple well bores. In this case, we have 1 well bore per well in this particular file, but you can have multiple well bores as well. I'm just going to select all of these wells. So there's 2 ways of doing that. I can click the top one and then select one further down like you're used to, or I can click this symbol on the right of the folder. So this symbol is select all, basically. So now I have selected all the wells. And by doing that, I have the property panel of my selection underneath. So here I can say, what do I want to do with this selection of data? I can go into the wells tab and do something about the radius. So if I put the radius to 8, you can see the wells are now much more visible. So this is where you adjust the radius of the well. It doesn't have anything to do with the actual well. It's just a visible result in Fieldap. So I tend to use 5 on my wells because then I can see them very clearly. You can also see here that you have a checkbox saying, is it from sea level? Yes or no. Sometimes the wells are from the rig. So the first measurement is actually from the drill deck. And this is something the drilling engineer will know. So there's different standards there as well. Some like to just take it from the first target, the spud location and down, but some also bring in the drill rig, from the drill rig down to the seabed. If you know that it is from the sea level, you can then press this button and then all the wells will be elevated up to that level. I'm not going to do that now. So right now we have a reservoir and we have a seabed and we have some wells. So if I go back to my 2D, this is how it looks. If I zoom in, I can see all my wells are these red dots. And I can also see that the name of the wells are displayed. So there are multiple wells going from one wellhead and down. And the names are displayed. You can move them around if you want to. I don't like to display the well name, so I want to hide it. So I have still selected all the wells in my tree view, so I can just go to common and turn off the label. This is where you turn the name on and off. You can also change the colors of them if you want them to have a different color. And you can have different colors on different wells, of course, so you can identify what is what, production or injection or gas. So I'm happy with this. So now I have a seabed, I have some wells. So let's start to bring in some mapping data. And I need to know where to get my mapping data. And this is something that we're going to discuss with your GIS people. But I have a mapping site here in Norway that I can bring in. And it's on the npd.no. And you can use the same link if you want when you try this later on. This is the Petroleum Directorate in Norway, and they have a map page that is very good. So I'm just clicking the facts, and in the facts page, they have map services. And here they are. So this is the ArcGIS map service from the API of the ArcGIS. And this will be the same as your mapping department can say that we want to serve you a mapping service of Page, for instance, or some other project. You just need to get this URL from that particular server. And you want the get capabilities. If I click it, you can see how it looks. It's a XML output looking like this. So this is what we want. I'm just going to copy this URL by Control-C, go back into Fieldap, and say create a WMS service. And I will get this window. So in the URL, I'm pasting in my mapping data from NPD, and you can see that it's already getting the data now. So in the bottom here, you can see fact maps. Oh, bless you. In the fact maps, you can see the different data that the NPD serves. So this is what I talked about earlier. Your mapping people can then decide what kind of data is interesting to serve on the map that they want to create for you. Maybe licensing is not important, so they will remove that. So this is what is served by the NPD. What I'm interested in is well bores. I want facilities and pipelines. And I also want to see the hydrocarbon. That's the data I want right now. So I'm just ticking those boxes. And nothing happens yet because I haven't chosen my CRS yet, the projection system. So if I click here, you can see that this list is what the NPD is serving, only this. So one of these are the correct one. And you need to know which one, because if you take the wrong one, the map will be very, very offset. And this is the 32, 29, 30. This is the North Sea of Norway. It consists of these 7 UTM zones. And I believe I'm in 31. I'm not sure, but I'm going to try 31. And you can see now, boom, the map just appeared in the background. If I choose 30, some other map will appear. So this is something you can play around with as well. But 31 looks promising. I think it's the correct one. And I can choose the format. It's an image format. So I'm choosing PNG because PNG is very fast over the internet, doesn't require any compression, and it's also transparent if I wanted to. So I'm going to go for this. Up here, you can see that you also have the ability to use a proxy, and you can use Windows credential or use authentication. I'm pretty sure that your mapping server internally will require Windows credentials. So then you just click that, and you're able to use your Windows credential that you use to log on to your computer to access the map. Some third-party mapping servers requires username and password because you pay for the subscription. Then you can you can choose that and just write your username and password. So I'm pressing OK now. And if I zoom out, you will see that the map will re-render automatically. So this is the map of the North Sea of Norway. And this is the data they serve. And the data I selected that I wanted to see. So if I zoom in on my area here, and I go to my project view, my layers, and I remove 3D surfaces, you can see that underneath my bathymetry is the Volva hydrocarbon. So I'm in the right place. And I can see here that there's some pipelines going straight through. So this is existing gas pipes on the North Sea. This is information that is useful to know for me. And these pipelines, since they exist in the map, I can actually import them as objects if I want to. But you don't need to because you can see them. I know now that I can't have anything crossing here. So that's valuable information for me. And I'm pretty sure that you have an extensive mapping database in-house that has a lot of this as-built, as-laid engineering information that is very useful to get into the project. One thing that I don't think Olav mentioned when he went through the future roadmap is that the next version also have logs. So you will see which user uploaded the bathymetry, for instance, and what was the source, what was the name of the file that user took the bathymetry from. So it will be more information about the data as well. So you can then see the date it happened and the name of the file. So if the bathymetry gets updated, you get better surveys. You're able to identify that and then re-upload new bathymetry, for instance. It's also useful for project management. If you're doing a collaborative project and you want to know who moved the FPSO or who moved the drill center, you can go into the log by clicking on the object and see who did it and when. And this is also something you can put into the user role system, so people won't be allowed to move an object after an object has been validated and locked, for instance, by a project manager. So anyway, we have the map, we have some wells, we have bathymetry, we have reservoir. So I want to build something now. I'm just going to turn on my reservoir again and my bathymetry. I don't really need the map to be live all the time. So this is the eyes you see in the project view is where you can enable and disable data. So if I turn off VMS, the map is gone. And I can quickly just turn it on again if I want. So this is a way you can turn on and off very easy. So this is what we're looking at, and we're going to try and create some layout to get something from these wells. So the first thing I'm going to do, if we start here, I'm going to place some equipment here. So we need something. And this is a typical satellite scenario. So again, I'm just going into my asset library. And if I want to, I can also explode the entire library by clicking this symbol. So I can then see a list of all the objects very easily. I can also search. So if I want a plet, you can search for plets. You can search for manifolds or whatever you want. So I'm just going for an XMT here, the deep water one, even if I'm in shallow water. I can actually use the shallow water one, but I'm going to use the deep water one. I'm dragging it in, and right now my Christmas tree is very, very small compared to that huge well that I have. And this is because I emphasized or enlarged the diameter of the well. So I can go back to wells, select all of them, and say, well, let's put it to 0.3. So now the well has a little bit of a more sane size. And I'm clicking my Christmas tree, and I can just put it here. So now my Christmas tree is in the location I want it to be, and I can rotate it by using this handle here. Or I can go in and set the heading here by inputting a number. That is also possible. So this is the property view. So everything you select, you will have the ability to modify in the property view. So if I select the seabed, I can do something about the seabed. The opacity of the seabed can be controlled, for instance. You can scale and rotate the seabed, but I'm not positive you want to do that. You can also choose some other interesting things here that I will show you later on the seabed, on the layers. Clicking a Christmas tree gives me the ability to manipulate the Christmas tree. I can give it another name. I can say drill center 1, for instance. So now it's called drill center 1. I can show the name by clicking here. If I zoom out a bit, you get the name, and the name can be placed wherever you want it to be, and it will be relatively locked to that position. So I'm going to have it here. That's a nice place. And you can then also choose the size of the name, of course, and the color of the name, if you want to do that. So this is my drill center 1. And now I need a plat to connect to that Christmas tree. So I'm just going to search for a plat. I'm going to use a vertical connector, drag it out, let go in the project, and do the same exercise. Just rotate it to where I want it to be. So the Christmas tree, I want it to be facing this way. I want my plat to be here. So let's say that you have some input saying the length of the jumper that's going to be there. And you want to try that out. So all these assets has connection points. And I'm going to click. You can see they react when the mouse is hovering above them. I'm going to click one of these points, and then I automatically get this connection. If I zoom out, it's still there. If I click and drag, it's still there. So where do you want to put it? Well, I'm zooming back into my plat and putting it there. So now I have a connection between my plat and my Christmas tree, and they are locked together like this. So let's say that you have an input saying that the jumpers should be about 48 meters. Okay, I click it, and I go in here, and I can see it's 28 meters. So I want to show the length of this connection on my screen here. To do that, I just go into connections, and here we have a lot of options again. You can choose what kind of connection is this, and this is the list. Here is where I can choose. What do I want? I think I want an oil production. Okay, what type of connection is it? I want a vertical M-shaped jumper. All right, and then you can say show the length. And now suddenly the length is here. So now I can see 37 meters. And if I manipulate the position of either one of these, the length will automatically update. So 48 meters, what was the length that I wanted? So then you can very easily reposition it to 48 meters. So let's say I'm satisfied with that. So let's go a little bit further. I'm thinking that the FPSO is somewhere over here. I'm going into my asset library again, and I can quickly just search for one. And I have multiple different FPSOs to choose from. So I'm going to choose a generic porch FPSO, drag out, let go, and there it is. The same thing applies. You can rotate it very easily. So I'm going to put it in this direction, and the porch is now on my left side. You can see that by the connections here. So I'm going to connect this FPSO to my Christmas tree over there. So I have some sort of riser base, and maybe you know the length or the diameter outside of the FPSO where this riser base should be. And using the ruler tool is up here in the top view, I can click on the middle of the FPSO and I can drag out a measurement tool, giving me an angle and also a length. So let's say that 250 meters that's there was the length that you wanted from the riser to the riser base. And then I go in and say, well, I need a riser base. I'm going for this one. I'm just going to put it there for now. And I'm going to adjust a little bit on the, let's put it that way, on the heading. And I'm going to connect to that point. So I'm clicking there, zooming out with my scroll wheel, finding my plet, scrolling back, zooming back in, and connect it there. So now I have a very, very straight line going from my riser base to my plet. I have selected my line when it's green. It has this aura around it. And I can then go into my connection and see that it's 1,675 meters long. Again, I can go into connections and I can say, I want to show the length. I want the text to follow the connection. And I want the text repetition to be this much. And it's upside down, so I'm going to flip it. So now I can see the length of my connection all the way. This is useful. And there's two ways in Fieldap to make a pipe route. One of them is to just click anywhere on the connection. You generate what we call an intermediate point. And if you click that point and drag it, you have this kind of spline functionality, which you're probably familiar with. So if I click here and drag that one up, I can then manipulate the route. And you can see that the length of the connection automatically recomputes when you do this. This is one way of doing it. To delete one of these points, you might have an accident and, oh, I created 3 points. I only want 1. You just press Shift, hold in Shift, and click it again. This is something that many people do not find. It's in the manual, but not many people read the manual. So just remember, hold Shift and click, and then you remove them. The other way to do it is to use the bend radius. So if I click there, I can then choose what is my bend radius. Let's say 80 meters. And if I click now, I will automatically generate an 80-meter radius that I have to be, I have to respect. I cannot go inside this circle. So you can see now that the bend that I get is 22 meters. The segment from the start of the bend to the connection on the plet is 142 meters. So this gives you valuable information as well. So let's have a little bend. And I want the bend to start at around 200 meters because that's what the installation guys told me. So here, I want the bend to start. And then you can go up and see, what do we do on this end? We want to come in at a given angle there. And it also needs to fulfill the 200-meter segment length from the riser base. So now I have a connection from the riser base to the plet with 2 bends. So this is what I want. And I know the length of my connection. It's 1,694 meters. If I click here in the connection profile, I can also see the profile of the seabed underneath. So I can see that I have a certain elevation going from the start where my plet is to my riser base. If I am in the connection profile window, you can see that if I manipulate this, it automatically re-renders the profile. This is a very flat seabed, but you can imagine if you have a more robust seabed, you will get a little bit more of a profile also. Same thing applies. Shift click removes the circle. I'm just going to keep this one there. So now I have this connection. I'm okay with it. It's defined as an oil production. And I'm going to connect my riser base up to my FPSO. So I do the same thing and just click this connection point. And I go to my FPSO and choose my porch entrance there. And now you can see the profile going up to the FPSO. It's just a smooth wave like this. So if I go into 3D now, and I just rotate my camera, this is what it looks like. So the FPSO is in very shallow water. I don't think you would have used an FPSO in this place. But anyway, I want to create a riser here, not this slope. So what I can do, I can go into my property panel. I have selected my connection, and I can choose a lazy wave shape. So now we automatically just generate one based on the length and the depth. But what you can do is manipulate the position of that point, and that point. So if I'm in 3D like this, I can go here and I can drag this handle, and you can see the riser will adjust. So this is a way that you can try and figure out you know, the shape of your lazy wave, the one, so it looks more real. It will never be the same as an engineered lazy wave riser. It's just, you know, a visualization. So this is where we use tools like Entail or others that use Orcaflex to actually calculate the riser catenary and import the correct one. But as an early phase visualization, this is enough. And if I select my FPSO, you can move it around, and you can see that the lazy wave will always recompute based on the parameters that you set here. And here you can see our pipeline going all the way down to the actual plet. And from the plet, we have a M-shaped jumper going to the Christmas tree. And we can see that the M-shaped jumper is a little bit off because this is a vertical connector and this is a horizontal connection. And this is also something you can adjust by clicking the plet. I know I'm in the properties of the plet, and then I can click Asset tab. So now I can see my connection point. If I click that connection point, you have the orientation. I can set it to vertical. So now it looks more real. I can do the same thing on the Christmas tree, even if this one is actually a correct one. You can then go in here and say, well, I want this connection point to be of a vertical position. So that's kind of the extent of the details that we have in this version when it comes to how these connections are being drawn. And we have a lot of feedback saying that people want to adjust the height and also the width of the first bend and the last bend. And that is something that we're gonna provide in an update, a way that you can actually design these jumpers yourself. So it's not just a generic one like this. On a horizontal level, on the other hand, you are able to design them already. If I go here and quickly just take a plet again, well, let's take that one. And just for the fun of it, I'm just clicking this one, Control-C and Control-V will copy the Christmas tree. You just need to say allow the first time. Oh, what's an error message? It's interesting. Not sure what that was all about, but it's very easy to copy objects. Control-C, Control-V, multiple selection, do the same thing. I can now manipulate the whole selection coordinate-wise, or I can take Control-C and paste that whole thing again up here. So you can copy and paste huge amount of objects if you want, and then be able to rotate the selection also by holding in Shift while moving it like this. So that's a way to make it more efficient when you draw. If you draw one drill center, maybe the next one is pretty similar. You can then copy the entire drill center and just move it. I'm just going to show you the horizontal way of doing a jumper is like that. And I'm going in here and I choose, well, horizontal is actually not a part of the allowed connections for this one. Let me try with, see if this one is here. No, it needs to be enabled in the admin section. But what I can do is use do not hide sample, and let's see if I can do it with a straight line. And no bend radius on this one, sorry. So now I can do something like this. So I can kind of draw my jumper in a way, seen from above. And if I go into 3D now, you will see that it's like a horizontal spool. So that's what we're also going to do on the vertical ones. So it's very easy then to adjust the look of the spool. So that's how we draw basically. It's I don't think it's very difficult to do. I think the hardest part when you start using Fieldap is to understand the correlation between the objects in the stage, as we call it, and the tree view here and the properties down here. So when you master that, it's very easy to create layouts. And so metadata is a way to give objects attributes. None of these objects you see now does have any more value than the position they own, so the coordinates. Could be useful for some application. But what you really want is to be able to give them more richer value. So to demonstrate the metadata, I'm just going to create some metadata so we can actually show how it works. And I will probably delete them afterwards. Or if Steve wants, they could be there. But anyway, as an admin, I can do this. So I'm going back to into my administrative menu here. And here I can go into assets, for instance. Here I will see a list of all the assets. I can choose my Christmas tree. And you can see that it actually has metadata type. And this is a visual programming interface that we created. So it allows you to create some logic and define metadata in a proper way. So the type metadata is a choice box between production and injection. And you can see that it has a cost attached to it. I think it's a test number. This is where you can put IDs in to fetch the cost from your surf system. So this is where you can tie that into that system. So it actually will fetch a cost from a different database. But let's say type is okay. We need to know if it's a projection or an injection tree. Maybe we also want to know, does it have a choke? So I'm going to create choke. And then that could be a Boolean value. Yes or no. Default, no. Does it have a cost? You can also put that in here. Then we can have choke definition. And then say the choke definition is a choice between type 1, type 2, so on. Then you can say choke definition will only appear if choke equals true. So that's where you can make this logic appear. Then we can also say pressure rating. Could be, whoops, something that you want to have in there. And that could be a numerical, for instance, saying that this is something you want to type in. And the default is 5,000. So this is where you just add on the different metadata you want to appear when somebody clicks a Christmas tree. And this is where you need to do some thinking because it's very hard to define this for a whole organization. So all the metadata can be generated through the API. So there's a lot of interesting standardization programs going on when it comes to metadata in the oil and gas. You have the OSDU program, and you have the CIFOS, I think it's called, and you have different others. And we are following those programs very closely because we wanted to kind of supply that as a service that you can choose. You can say that I want this project to be OSDU compliant, and then all the metadata will automatically update to become an OSDU standard, for instance. So that is fully possible. You can populate all the metadata through the API and then keep the master record in the different database. So if something changes over time, you just change it in the database and then you update the metadata definitions. So that's a possibility. And but what we see is that most of our clients, they don't have any of that. So they want to define it inside of Fieldap first to see that it works. And then they take a data dump out of our API, and then they build a database around it. So different ways to the same goal, but you will end up with a fairly big list, I think, of metadata that will be suffice to cost analysis, but also then flow assurance and feasibility, production forecasting. You need a lot of different divisions and silos to be a part of it. It's a bit of a hard work, but it's very, very good when you're finished. So I'm just going to just show you the ones that I created now. If I click this pipeline again now and go to metadata, you will now see that the new ones that I just created is here. So inner diameter, I can set that to 16. Coating, concrete, steel type, carbon. So now I attach some valuable attributes to this pipeline. Same thing with the Christmas tree. Now I have the ability to say it's a production tree with a choke, with a type 1 choke definition, with a pressure rating of 5,000. So this is just to show you just very quickly how it works with metadata. And metadata is available for any object. Wells, bathymetry, reservoir. We have virtual objects. That means not visible objects that you can link in. And you can make quite a complex metadata structure that will give you a lot of value in the project. Another one thing you can do is if you want to show this to someone who is not a part of the Fieldap license, it could be a manager, it could be a partner, collaborator, client. You can go up here and you can say, make a link, a viewable link for me that is unlimited, or it's viewable 20 times until tomorrow. And you generate the URL, you copy it, and you email it to someone. And they are then able to go in and see the project in 2D and 3D. They can't draw anything, move anything, but they can view. And if you do some changes, they will see the change real time. So it's very useful in meetings and so on. So that's just 1.5 hours. I hope you have enough now to start fiddling a bit around with it. If you have any questions, just be aware that we have a help desk, which is very good. Help.fieldap.com. If you have any questions, just please let us know. You can submit whatever you want. If you find a bug, submit a bug request here. If you have a suggestion, whatever it is, and we will take a look at it as fast as we can. We also have a community that is open, so you can join and ask questions. And there's also a manual here for the online documentation. So here everything is explained. So you will find the answer to most of your questions actually in this one. And we also have an API documentation if you want to take a look at that. That's more developer stuff, but it will give you an idea how you can start making integrations and utilize the data that you actually put into the project.